Hello, PascoMath grade 8 teachers. Today we're going to explore 8.EE.1.4. We're going to pack the standard, look at what the teacher should be doing, some things the students should be doing, as well as addressing some misconceptions that might occur in the classroom. So let's get started. So 8.EE.1.4, the standard reads, perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. Use scientific notation and choose units of appropriate size for measurements of very large or very small quantities. Interpret scientific notation that has been generated by technology. So that was a lot, and so let's unpack it a little bit. So the standard builds on previous 8EE standards. The quantities in the problems can be expressed in scientific and decimal form. Students focus on size of measurement to choose appropriate units for the context. And then the standard calls for the use of technology and be able to interpret the scientific notation displayed. And so we'll talk about that in a little bit, and I'll show an example on a calculator. So let's look at what the teacher does. So the teacher needs to pose problems that require students to perform operations with numbers written in scientific notation. Present problem-solving opportunities for students to choose correct units of measurement, and provide students with calculators to perform operations that result in the number displayed in scientific notation, and facilitate that discussion about what that notation on that display means and how it is in the form of scientific notation. And then provide other opportunities for students to interpret scientific notation expressed with technology. And so again, I'll show you what that looks like in a second. Some things the students should be doing. Perform operations with numbers written in scientific notation. They need to solve both mathematical and real-world problems because apparently they're different. I'd like to focus on the real-world problems, that context piece. Choose correct units for very large and very small numbers when solving problems. And then we also want them to discover and interpret the rules for scientific notation when displayed on a calculator. So let's get a little bit of the math here. And so when we address misconceptions, when students are performing operations with numbers and scientific notation, some students get overwhelmed keeping track of everything they should do. And so let's just work through an example. Let's say that, let's go 8 to the times 10 to the 5th. And let's multiply that by 17 times 10 to the 9th. First, we can have some discussion like, is this currently represented two numbers multiplied in scientific notation? And now students will realize, hopefully, that the second number there is not in scientific notation, so we have to do a little bit of work. And so to represent this in scientific notation, we need to have a number between, can be 1, but less than 10. And so 1 and 7/10 works, but if we do that, we need to increase the power by 1. And so now that number is written in scientific notation. So those two numbers are equivalent. And so now I have 8 times 10 to the 5th. We're multiplying that by 1 and 7/10 times 10 to the 10th. So as it says, we should really encourage students to mark up the text and group the numbers and powers together. So we have the commutative property, like we should use it. And so I know I have 8 and 1 and 7/10, so I can rewrite. I also have my powers here, and so I could group them together. Now we can rely on some prior knowledge. So we know what to do with powers from 8E.1.1. And so it's same base, multiplying exponents. The students should know at this point that we can add those. So that's 10 to the 15th. Over here, we have 8 times 1 7/10. Well, that's 13 6/10. And some students might be happy with this. But as you know, like we need to write that in scientific notation. And so we're not quite done yet because 13 is greater than 10. And so then we need to do just a little bit more work. And so to represent this in scientific notation, we would need to write it as 1 3600ths times 10 to the 16th. And just to check the work here, make sure I'm right, I'll give the opportunity to use our FSA approved TI 30XA here. And so when I'm using that because was it part of the standard talked about interpret scientific notation that's been generated by technology. And so if I just use the calculator here and just type in the problem, I think I had 8 times 10 to the 5th times, I'm just going to go straight from the problem, 17 times 10 to the 9th. So I get this 1 and 3600ths and then the 16. And so students should be quick to pick up on like how the technology is writing the number in scientific notation, but the standard calls out, like explicitly wants students to discover how to interpret a display like technology when it's represented in scientific notation. So to be able to translate that back to the 1 and 3600ths times 10 to the 16th. So that's explicitly called out in our standards. So students need experience, not just with the TI-30XA, but maybe if they're on the internet, like how does Google represent the number? How does a TI-84 represent it, and things like that. So just don't focus on the TI-30XA, but calculators in general. Thank you for watching. If you have questions, feel free to contact me or your regional specialist, and thank you for making PascoMath more awesome.